All right, so I just recorded this video only to find out that I didn't actually record a video. So I'm going to start over and I'm going to be crabby about it. This is going to be geometric rather than arithmetic. And yesterday in arithmetic, to do that, you went from term to term by adding. With geometric, you're going to move term to term by multiplication. So in geometric sequences, you're going to be using multiplying or dividing to go from term to term. And so we say that they have a common ratio, not a common difference. Ratios are division. So we have an explicit rule. There's two formulas, just like yesterday. One is kind of for everything, and one is for sums. So on your packet, you're going to see there's two formulas. One is for finding the sums, that's why it's an S, and one is just for kind of finding all the other information. A1 is going to be your first term like it was yesterday. A sub n is going to be kind of any future term like it was yesterday. N is going to be the number of terms in your list. And then R is going to be the new thing, and it's going to be your common ratio. What are you multiplying or dividing by to go from term to term? To find it, you can take any term in the list and then you divide it by the previous term, like the one in front of it. And then you can figure it out. Or you can just use your brain and look, and then for some people that's enough. So this is asking me if they're geometric, and if they are, I'm supposed to tell it the ratio. But when I look at this one, the pattern is not geometric. Here I'm adding 4, so that's arithmetic. So that's a no, it's not geometric. Let's do this other one I can see. Here, if I'm looking at this, either I recognize the pattern or I don't, and I take out my calculator and I divide these, and I find they're getting smaller, so I'm definitely dividing as I go. This reduces to 1/5, meaning I'm dividing by 5. Each number is 1/5 of the previous number. So my ratio is 1/5. And so then this is a yes, this one is geometric. Here you might be able to see the pattern a little more, but if not, again, you can use your calculator. Take any term and put it over the one in front of it, you get a 3. You can test one of these further down the line. Take that term, put it over the one in front of it, you get a 3. So this one is geometric, so this is a yes, and my common ratio is 3. So when I have a bigger than 1 number, the numbers get bigger, and then when they're getting smaller like they were over here, I was dividing by 5, so they got smaller. Here, if you look at it for a little bit, you're going to see that these go down by 3. So this one's arithmetic, so the answer is a no, it's not geometric. So let's try. It says to write the explicit rule. Okay, so that up here is the explicit rule. These are easier because you don't have to simplify them. You say, okay, here's my first term. So an equals my first term. And then in parentheses, I'm going to put my ratio and then n minus 1 power. And if you look at this, we just did this one up here. So my ratio is a 3, and that goes in there. And that is my explicit formula. And I could use it to find any other terms that I needed to. Where am I on here? Sorry. Okay. So let's see. Write a rule and then find the 7th term. Okay. Well, if you look here, these are going to have a ratio of 5. I'm multiplying by 5 each time. 4 times 5 is 20. 20 times 5 is 100. If you can't find that in your brain, you just divide and see that that's 5. Test out another pair further down the line. Anything divided by the one in front of it. So I'm like, okay, it's 5. So my formula is a sub n. Any term will be the first term, and then in parentheses, my common ratio to the n minus 1 power. Done. To find the 7th term, I'm going to have 4, and then 5, and then 7 minus 1 power. So if I do that on my calculator, the 7th number will be 62,500. Here, this is kind of weird. You can see the numbers are getting smaller, not because it's negative, but because the numbers themselves are getting smaller. 152 down to 76, down to 38, down to 19. If you don't recognize the ratio, you can take any term and divide by the number in front of it. You're going to get negative 1/2. So that is my R. So any number will equal the first number times my ratio to the n minus 1 power. Then to find the seventh one, I just plug in a 7. And it makes your life easier to do that like as a decimal on your calculator, that's fine too. And when I do that, my seventh term is 2.375. Okay, this is going to be a little, well, this one's easy, the other one's tricky. So this is saying write the explicit rule, which is the an equals a1r to the n minus 1 power. It's telling me a1, it's telling me r, easy peasy. Any term will be the first term times that common ratio to the n minus 1 power. So if they give you the first term in the ratio, it's pretty easy. But if they don't, you have to do some thinking. So like here, I know this. So I know that a sub n will equal 5, and then I just need the common ratio. But I have to figure it out. So all I know is that the sixth term is 160. So what I would do is say, hey, if I'm going to end at the sixth term, I would have started at the first term, used my common ratio, 6 minus 1 times. So I would have had 5 spaces. Like I would have used that 5 times. Sorry, I'm trying to erase that so it doesn't look like something else. Okay, so what is my sixth term? 160. What is my first term? 5. Don't know my common ratio, but I know that I use it 5 times, 6 minus 1, to get from the first term of 5 to the sixth term of 160. Because if you have the first term here, second, third, fourth, fifth, sixth, a sub 6, you're going to go 1, 2, 3, 4, 5 steps, meaning you would have used that r 5 times. So I divide by 5 here. Now I have 32 equals what to the 5th power? You can either use your blue card or you can multiply the power by a 5th over there, which just cancels out. Oops, sorry, I should put that over here. And so then I need the 1/5 power over here as well. Because then that cancels, and r is 2. And all I got to do is plug that in here, and I have my formula. So it's definitely tricky. You got to figure out what that ratio is. All right, don't panic. All we're going to do here now is add stuff up. But instead of having to write them all out and add them, we're going to use this formula. It's all common things. This is a sum. This is going to be my first term. R is going to be my ratio, and you'll see that it's in there twice. N is going to be the number of terms you're adding up. So everything is the same as it has been. So here it says to find 3 terms, but we really are adding 16. So we're going to add up 16 terms. We need the first term, which we find by plugging in a 1. And that's going to give us 4 times 3 to the 0, which is 1, so 4. Here we're going to plug in a 2, so that's going to be 4 times 3 to the first power, so 12. And the third term is 4 times 3 to the 3 minus 1, so 4 times 3 squared, so 4 times 9 is 36. And then I'm not just adding those 3 up, I'm adding 16 of them up, so I have to use the formula. It wants the first term, which was a 4, and then 1 minus my ratio, and if I look back at the problem, the ratio is always inside the parentheses raised to a power. So my ratio is 3. Then I have to put it to the power of n, which is the number of terms. So that's a 16. And on the bottom, I just have 1 minus r. Now these are tricky, and I would highly recommend that you do this first on your calculator. So let's do that. Let's do 1 minus 3 to the 16th. You're going to get a really big number. 1 minus 3 raised to the 16 power. I got like negative 430467720. Then I'm going to do this. So I'm dividing by negative 2 because 1 minus 3 is that. So I'm going to divide by negative 2. And then I'm going to multiply by 4. So adding those 16 terms up, I'd get 860934440, which is a lot. But I'm just using the formula. And then this is also tricky because I'm supposed to add them up, but I don't know how many there are. So I don't know n. So when I go to do my formula, I don't know n. I do know the first term, and I can see by looking at this that my ratio is 2. I'm multiplying by 2. N to the power, or the power of n will go up here because that's the formula. And then on the bottom, I do 1 minus r. But I have to find n. So you have to use the other formula again. You would use your last, or your term equals first term, common ratio, however many times you need it. So to get from 768, starting at 3, using a common ratio of 2, I'm trying to figure out how many times I used it, my n. So dividing by 3, I have 256. And so now I have to think or use my blue card to figure out what power of 2 will make 256. And if you look at that, you end up with 2 to the 8th power. And so if I need this top to be 8, that top power, then I would need my n to be 9 because I'd have to add this over. So you do all of this work here, but you're trying to find n so that you can go back up into your adding formula and plug in that 9 here and here. Then I do this part on my calculator, 1 minus 2 to the 9th, get 511, negative 511, dividing by this, but 1 minus 2 is negative 1, so I divide by negative 1, and then I times my answer by 3 and get 1533. So there's 2 formulas, but when you don't have what you need for this formula, you get stuck going back to the other formula to find what you need, just like yesterday. But today, we have a common ratio because you're multiplying or dividing to go term by term rather than adding or subtracting. That's a lot. See you guys.